NEC Section 400.13 states that electrical equipment shall be installed in a neat and workmanlike manner and shall be accessible for examination, adjustment, servicing, and maintenance. Conduits and other raceways shall not be used as a means of support. NFPA 70E Article 110.2 states that electrical equipment and installations shall be free from recognized hazards that are likely to cause death or serious physical harm to persons or property. NEC Section 400.8 states that conductors shall not be installed in raceways in such a manner as to cause physical damage to the conductors or raceways. NEC Section 400.3b states that conductors shall be securely fastened in place and shall not be permitted to move freely within the raceway. These codes indicate that running multiple power strips with surge suppressors to handle the electrical load of 4 cubicles is not a safe or code-compliant practice. The power strips and surge suppressors are not designed to be permanently installed in a raceway, and they could move freely within the raceway, causing damage to the conductors or raceways. Additionally, the power strips and surge suppressors may not be accessible for examination, adjustment, servicing, and maintenance. Instead of running multiple power strips with surge suppressors, the installer should install a single duplex outlet in each cubicle. This will provide a safe and code-compliant way to power the electrical equipment in the cubicle. Now, let's delve deeper into the reasons why using power strips in the manner described is problematic and explore compliant alternatives. Firstly, the National Electrical Code, or NEC, is a comprehensive set of standards that governs electrical installations for safety. It's designed to protect people and property from hazards that can arise from the use of electricity. Several sections of the NEC are relevant to the scenario involving powering multiple cubicles from a single duplex receptacle via power strips. Secondly, NEC Section 400.13, which mandates a neat and workmanlike manner of installation, is crucial. This requirement isn't just about aesthetics, it's about ensuring that electrical installations are done in a way that minimizes the risk of damage, wear and tear, and potential hazards. When power strips are used in a haphazard manner, particularly in a commercial setting, it's easy for them to become damaged, overloaded, or improperly supported, violating this fundamental principle. Thirdly, the NEC emphasizes accessibility for examination, adjustment, servicing, and maintenance. Power strips, especially when buried under desks or behind cubicle walls, are often difficult to access. This lack of accessibility can impede routine inspections, necessary repairs, and timely identification of potential problems. If a power strip malfunctions or shows signs of wear, it needs to be readily accessible for replacement or repair. Fourthly, NFPA 70E Article 110.2 raises concerns about recognized hazards. Electrical equipment and installations must be free from recognized hazards that are likely to cause death or serious physical harm to persons or property. Overloading power strips, using damaged power strips, or creating tripping hazards with their cords can all lead to dangerous situations. These hazards can include electrical shocks, fires, and physical injuries. Fifthly, NEC Section 400.8 prohibits installing conductors in raceways in a manner that could cause physical damage to the conductors or raceways. While a power strip itself might not be a conductor in the strictest sense, its cord is. Stuffing multiple cords into a raceway can cause abrasion, overheating, and eventual failure of the conductors within the cords. This is especially true if the raceway is not adequately sized to accommodate the number and size of the conductors. Sixthly, NEC Section 400.3b requires conductors to be securely fastened in place and not permitted to move freely within the raceway. Power strips and their associated cords are not designed to be securely fastened within a raceway. Their flexibility and lack of secure mounting provisions mean they can easily move around, increasing the risk of damage and potential hazards. Seventhly, power strips, particularly those with surge suppressors, are typically designed for temporary use and are not intended for permanent installation within a building's electrical system. They are not subjected to the same rigorous testing and certification standards as permanently installed electrical devices. Using them as a long-term solution to power multiple cubicles can lead to premature failure and increased risk of electrical problems. Eighthly, it's essential to consider the cumulative load in the circuit. Each cubicle typically contains a computer, monitor, task lighting, and other electronic devices, each drawing its own current. When you combine the loads of 4 cubicles onto a single duplex receptacle via power strips, you run the risk of overloading the circuit. Overloading can cause the circuit breaker to trip frequently, which is disruptive and inconvenient. More seriously, it can lead to overheating of the wiring and potentially a fire. Ninthly, the use of surge suppressors in power strips adds another layer of complexity. Surge suppressors are designed to protect electronic equipment from voltage spikes. However, they have a limited lifespan and can degrade over time, especially if they are frequently subjected to surges. If a surge suppressor fails, it may no longer provide protection, and it could even become a fire hazard. Tenthly, the NEC provides specific guidelines for installing receptacles to meet the needs of office spaces. Instead of relying on power strips, a more code-compliant solution is to install a sufficient number of duplex receptacles in each cubicle. This can be accomplished by tapping into existing circuits or by installing new circuits specifically for the cubicles. Each receptacle should be properly grounded and installed in accordance with the NEC. 11thly, consider the use of modular power distribution systems designed specifically for office furniture. These systems typically consist of a series of interconnected receptacles that are wired back to a central power source. They are designed to be easily installed and reconfigured as office layouts change. Modular power distribution systems offer a safe, flexible, and code-compliant way to power multiple cubicles. 12thly, another option is to install multi-outlet assemblies. These are similar to power strips but are designed for permanent installation. They typically have a metal housing and are wired directly into the building's electrical system. Multi-outlet assemblies can be mounted under desks or along walls, providing a convenient and code-compliant way to provide power to multiple devices. 13thly, it's important to ensure that all electrical work is performed by qualified and licensed electricians. The electricians are trained to understand the NEC and to install electrical systems safely and correctly. They can assess the electrical needs of the office space and recommend the most appropriate and code-compliant solutions. 14thly, the amperage of the circuit feeding the receptacles must be considered. For example, a typical general-purpose circuit is rated for 20 amps at 120 volts. This means the total load in the circuit should not exceed 2400 watts. If the combined load of the 4 cubicles exceeds this limit, a separate circuit will be needed. 15thly, proper grounding is essential for electrical safety. All receptacles and equipment must be properly grounded to prevent electrical shocks. The grounding system should be inspected and tested to ensure that it is functioning correctly. 16thly, arc fault circuit interrupters, or FSIs, provide enhanced protection against electrical fires. FSIs are designed to detect arc faults, which are dangerous electrical conditions that can cause fires. The NEC requires FSIs to be installed in many areas of a building, including branch circuits that supply receptacles in office spaces. 17thly, ground fault circuit interrupters, or GFCIs, are designed to protect people from electrical shocks. GFCIs are required in areas where there is a risk of contact with water, such as bathrooms and kitchens. While GFCIs are not typically required for general-purpose receptacles in office spaces, they may be required in certain situations, such as near sinks or other sources of water. 18thly, when installing new circuits or receptacles, it's important to use the correct type and size of wire. The wire size must be appropriate for the amperage of the circuit and the distance of the run. Using undersized wire can cause overheating and potentially a fire. 19thly, the NEC specifies minimum spacing requirements for receptacles in office spaces. Receptacles must be spaced so that no point along the wall line is more than a certain distance from a receptacle. This ensures that occupants have convenient access to power without having to use extension cords. 20thly, consider the long-term needs of the office space. As technology evolves, the electrical demands of office equipment are likely to increase. It's wise to plan for future needs by installing sufficient capacity in the electrical system. 21st, regular electrical inspections are essential for maintaining a safe and code-compliant electrical system. Inspections should be performed by qualified electricians and should include a thorough examination of all electrical components, including receptacles, wiring, and circuit breakers. 22nd, document all electrical modifications and installations. This documentation should include wiring diagrams, circuit schedules, and inspection reports. Maintaining accurate records will help ensure that the electrical system is properly maintained and that future modifications are done safely and correctly. 23rd, train employees on electrical safety procedures. Employees should be aware of the hazards of electricity and should know how to use electrical equipment safely. They should also be trained to recognize and report electrical problems. 24th, be mindful of the placement of power cords. Avoid running power cords across walkways or under carpets, as these can create tripping hazards and can damage the cords. Use cord protectors or cable management systems to keep cords out of the way. 25th, never overload power strips or extension cords. Overloading can cause overheating and potentially a fire. Use a power strip with a surge suppressor to protect electronic equipment from voltage spikes. 26th, replace damaged power strips and extension cords immediately. Damaged cords can pose a serious electrical hazard. Inspect cords regularly for signs of wear and tear. 27th, do not attempt to repair electrical equipment yourself. Electrical repairs should be performed by qualified electricians. Attempting to repair electrical equipment without proper training can be dangerous and can void warranties. 28th, avoid using extension cords as a permanent solution. Extension cords are intended for temporary use only. If you need a permanent source of power, install a receptacle. 29th, unplug electrical equipment when it is not in use. This will save energy and reduce the risk of electrical fires. Unplug appliances when you go on vacation or when there is a power outage. 30th, keep electrical equipment away from water. Water can conduct electricity and can cause electrical shocks. Do not use electrical equipment near sinks, bathtubs, or other sources of water. 31st, use the proper type of light bulb for each fixture. Using the wrong type of light bulb can cause overheating and potentially a fire. Follow the manufacturer's instructions for the maximum wattage allowed for each fixture. 32nd, ensure that all electrical panels are properly labeled. Labeling electrical panels makes it easier to identify circuits and to troubleshoot electrical problems. Circuit directories should be kept up to date. 33rd, use covers on unused electrical outlets. This will prevent children from inserting objects into the outlets and getting an electrical shock. Outlet covers are inexpensive and easy to install. 34th, never remove the grounding pin from an electrical plug. The grounding pin is there to protect you from electrical shocks. Removing the grounding pin can create a dangerous situation. 35th, use surge protectors to protect sensitive electronic equipment. Surge protectors can help to prevent damage from voltage spikes caused by lightning or other electrical disturbances. Choose surge protectors that are rated for the amount of protection you need. 36th, avoid running electrical cords through doorways or windows. This can damage the cords and can create a tripping hazard. Find an alternative route for the cords. 37th, keep electrical equipment clean and free of dust. Dust can accumulate on electrical equipment and can cause it to overheat. Clean electrical equipment regularly with a soft cloth. 38th, be aware of the location of underground utilities before digging. Call your local utility company before you dig to avoid damaging underground cables or pipes. Damaging underground utilities can be dangerous and can disrupt service to your home or business. 39th, if you experience an electrical shock, seek medical attention immediately. Electrical shocks can cause serious injuries and can even be fatal. Even if you feel fine after an electrical shock, it's important to see a doctor to rule out any internal injuries. 40th, be aware of the symptoms of electrical overload. Symptoms of electrical overload can include flickering lights, warm outlets, and tripped circuit breakers. If you experience any of these symptoms, reduce the load on the circuit and have it inspected by an electrician. 41st, use caution when working with electricity during wet weather. Water conducts electricity and can increase the risk of electrical shock. Avoid working with electricity outdoors during rain or snow. 42nd, know the location of the main electrical disconnect switch in your home or business. In the event of an electrical emergency, you need to be able to quickly disconnect the power. Make sure everyone in your household or workplace knows where the disconnect switch is located. 43rd, consider the use of tamper-resistant receptacles, especially in areas where children are present. Tamper-resistant receptacles have a built-in safety mechanism that prevents children from inserting objects into the slot. 44th, be aware of the dangers of aluminum wiring. Aluminum wiring was commonly used in homes built in the 1960s and 1970s. Aluminum wiring can be a fire hazard if it is not properly installed and maintained. If you have aluminum wiring, have it inspected by an electrician. 45th, use a qualified electrician for all electrical work. Electrical work can be dangerous and should only be performed by someone who is trained and experienced. A qualified electrician will ensure that the work is done safely and in accordance with the electrical code. 46th, get a permit for all electrical work that requires one. Most jurisdictions require permits for certain types of electrical work, such as installing new circuits or modifying existing wiring. Obtaining a permit ensures that the work will be inspected and that it meets the electrical code. 47th, ask your electrician about energy-efficient lighting options. Energy-efficient lighting can save you money on your electricity bill and can help to reduce your carbon footprint. Consider using LED lighting, which is more energy efficient than traditional incandescent or fluorescent lighting. 48. Install a whole house surge protector to protect your entire electrical system from voltage spikes. A whole house surge protector can protect your appliances, electronics, and wiring from damage caused by lightning or other electrical disturbances. 49. Consider installing a generator to provide backup power in the event of a power outage. A generator can keep your essential appliances running during a power outage and can help to prevent food spoilage and other inconveniences. 50th. Review your homeowner's insurance policy to ensure that you have adequate coverage for electrical damage. Your homeowner's insurance policy should cover damage caused by electrical fires, lightning strikes, and other electrical events. It's also important to ensure that your policy covers the cost of repairing or replacing damaged electrical equipment. By following these guidelines, you can help to ensure that your office space has a safe and code-compliant electrical system. Remember, electrical safety is not just a matter of following the rules, it's about protecting people and property from harm. Always err on the side of caution when it comes to electricity, and never hesitate to call a qualified electrician if you have any questions or concerns.